Folks, this is Jasper with the Southwest Madison County Fire Protection District in Madison, Mississippi. Wanted to show y'all a little bit more about pump operations. With the older truck, the 1999 International, we talked about putting it in pump gear, opening the discharges, setting the relief valve, and cooling the engine. Not going to go through that procedure because this is a 2012 Pierce, and that procedure is exactly the same. However, while a fireman from 1940 probably could have run that truck fine, it's a little bit different with this truck. For one thing, there's no throttle wheel anywhere. Also, there's no pressure relief valve anywhere. There's no control on it at all because this truck doesn't have one. The way that you want to pump this truck is same thing: water in, water out. I'm going to recirculate the tank fill. I've also got this passenger rear discharge is hooked up to the direct fill of the tank in the back. So I'm going to recirculate some water through here, but this has got its own pressure gauge. So this truck, what you have to do is you use the computer. The computer that controls the pump also controls the tank. You press mode, you can have a govern in pressure, or you can govern it by the throttle. Let's start off with governing by the throttle because that's the way it always worked in the past. I'm gonna go ahead and open up the RPM. You can see the pressure comes up as well. And if you look here, we're below zero, so the intake is sucking water out of the pump. We're at, let me run up to about 150 PSI. Okay, if I go to close this, we'll have less water running through the pump, so the volume will go down, so the pressure will go up. Same thing if I open it up so where more water comes out, the pressure goes down. Okay. Now, if I want to open up another line with a different pressure, I have to gate that line. So what that means is I don't pull it up. Don't pull it open all the way. I'm gonna set this one to about 50 pounds. All right. Now, watch what happens if I close this other line. Look at the pressure here and the pressure here. They go up. Now, if you were flowing big lines from a hydrant, that could be a real problem for the guy on this line. So, let's start over again. Instead of pushing in on the throttle wheel like on the other truck, you just press idle. Takes it back down. Press mode. Now this time I'm going to set it with PSI. I'll run it up. So my compound pressure is about 150. Now, if I open this up, the truck knows and it speeds the engine up. But if I outrun my water supply, instead of cavitating the pump, that will come on and I got to start over again. So I press mode, pressure, set it on about 130 or 120. I'll open this back up, flow water. If I open it up all the way, the truck increases RPM to keep up with it. Close it, it slows back down. Now watch what happens when I open up another line that's gated, that's got less pressure. All right, if I close this all the way to simulate somebody that has closed the line, watch what the pressure does. It comes up a little bit, but then the truck idles back down so that the person on this line doesn't have to eat the excess pressure. Again, I hope y'all can see that. I'm doing this on my phone. But that's the difference between modern trucks, is they're all controlled by the computer, just like the engine, the pump, and the controls are as well. This protects the guys out on the hoses by not putting too much pressure on them. It also protects the pump by, if you start to exceed the pump capacity and cavitate the lines, then it will shut down. If another truck was pumping into me, that pressure would be added from here. This would go up and this would go up as well. So if he was pumping into me at 20 PSI, it would add 20 PSI over here unless I backed off the throttle. The truck does that automatically. Now, you still have to be smart when you're pumping the truck, because you have to know what pressure to set these lines at, and you have to be able to calculate friction loss. The more water that you flow through a line, the more the friction loss is. That goes up. It goes up exponentially with the volume of water flowing through. It also increases, I think that's arithmetically, by the length of the hose. So there's algebra involved. I won't get into it. There's plenty of videos on that on YouTube. So again, if you have any questions about this, feel free to leave them in the comments section below. But if you're a firefighter, I recommend that you check with your commander training staff, because fire truck manufacturers will build anything that you can pay for, and your equipment may be different. Also, if you like this, please click like. Thank you and goodbye.